Hey, glad to see everybody here. And my name is Bing Yu. I'm a Senior Technical Director from Andis. My role at Andis is provide a processor roadmap and architecture as well. And today I'm going to talk about enhanced OPT for RISC-V and leverage the IOPMP and enable RTOS integrations. And for those of you who does not know Andis, I'm going to use this opportunity to introduce Andis before I go into the talk. Okay, we're a pure play processor IP company in the last 20 years. But since 2016, the inception of RISC-V, we jumped on the RISC-V bandwagon and supporting the RISC-V architecture. So we switched from proprietary architecture to RISC-V architecture, and we never looked back. And we are the founding and premium member of RISC-V and the RISC. RISC is a RISC-V software ecosystem organizations. And also we are the director of a board. We're also a member of a technical steering committee as well. And we're really actively contributing to the technical specification of RISC-V. And we hold many chair and co-chair positions. For instance, we're holding the chair of IOPMP, Paul, right here. He's the chair of IOPMP, which is secure. It's an integral part of today's talk. And also, I'm the vice chair of IME, Integrated Metric Extension. And also, RVP is a P extension for DSP, and Rich is the chair of the P extension. And so we are really actively contributing to the specification of RISC-V. And currently, we have a 30+ RISC-V Andis core. It ranges from 2-stage, 3-stage, 5-stage, and 8 stages in order to a 13-stage out-of-order processor core. And we have 400+ licensee, and we have 500 employees, roughly 500 employees around the world. And we have roughly a little bit below 100 employees in Northern California, which including our wholly owned subsidiary, Condor. You might have heard it. And we have 100K Andis side IDE user, and we have 17 billion plus unit of Andis power SoC. That made us the leading IP provider RISC-V processor. And we'd like to talk about the segment of our core is the same right now. And we're in the mobile phone, we're powering the Wi-Fi and the Bluetooth controllers. And also we have the MPU, MCU, and AIoT segment as well, like Renesas. And also storage, 5G network, and automotive. Automotive, we're in like infotainment system, and we're in MCU, automotive MCU, and we're in the sensor, like an image sensor, and in-cabinet radar sensor as well. And another segment that we have a great position in is a large-scale AI ML. And one of the customer, Rivals, about 2 weeks ago just announced they're being acquired by Meta, which is also our customer. So with the combining of Meta and Rivals, it will further strengthen the relationship between Andis and Meta. All right, let's get into the today's topic. Andis Sentry framework is an Andis security framework. And we're going to talk about how does the SoC architecture look like. Also, the Andis CPU and software stack of Linux OPT solution. And we're going to talk about boot sequence, which is important for the security. And we're going to talk about Andis Sentry roadmap. We will extend the Andis Sentry framework to the MCU-T security monitor, which is for the MMU-less single-core MCU. MCU-T will be great for the automotive ECU, which need to have a fast and predictable response time. when you talk about security, you cannot ignore the trusted execution environment. The processor needs to provide a confidentiality and integrity, and you also need to perform execution of environment isolation. That's had to do with the hardware and the software part of it. Here is a T solution for NDIS framework. NDIS core implement with PMP, stand for physical memory protection, provide the access protection from the heart. And IOPMP provide the access protection for the other initiators. And NDIS Sentry Secure Boot guarantee the integrity of the boot sequence, which I will talk about in the later slide. And the security monitor performing zone loading, isolation, and management. And OPTEE is the open source security monitor driven by NDIS and other RISC members for the application processor. And the MCU-T have a separate, and we're gonna have a separate slide talk about that. And MCU-T is a secure monitor for MMU-less single core MCU. We'll also talk another slide on that subject as well. And we are also providing the Linux reference port for OPTEE and RTOS reference port for MCU-T. And here's an example of SoC architectures. For the initiator, which including RISC-V hard, have two execution environments, RE and T, and also other initiator like DMA. And each bus initiator or hard executing environment has its own dedicated system resource like memory or peripherals. To enforce isolation of memories access from different hards execution environment, PMP, which limits the physical address accessibility by a hard, and invalidation memory access will be blocked by the PMP. And to enforce isolation of memory access from other bus initiator, an IOPMP, which will limit the physical accessibility by the bus initiator, and invalidate transaction will be blocked by the IOPMP. So here is the NDIS Linux plus OPTEE solution for application processor. The upper left blue box has a RE, which stands for Rich Execution Environment, which has Linux and all the application running in that environment. On the right is a T, Trusted Execution Environment, which is running Trusted OS. And you want to make sure that your RE cannot access any secure element. So if there is any demand to protect a sensitive asset, software developer can integrate the sensitive operation as an OPTEE trusted application to ensure the sensitive asset will not be leaked to the read. And OPTEE support RISC-V MMU page-based virtual memory, including SV39, SV40A, and the SV57. OPTEE manage standalone page table which are not accessible by Linux. The page of the trusted application are isolated by the MMU, enhancing memory isolation between the application, and OPTEE kernel virtual address can be optionally protected by the ASLR, which stands for Address Space Layout Randomization. And this solution utilize RISC-V standard SBI MPXY is a message proxy extension, and RPMI, which stands for RISC-V Platform Management Interface Specification, as a message protocol between RE and the T. And the Linux application can issue a message to OPTEE trusted application to request for the secure service. And the source monitor is essential component which is executed as the highest privilege level and manage RISC-V PMP entries to isolate memory regions. And And also in Andes OP-TEE solutions, OpenSPI acts as a secure monitor. And during the context switch of the two execution environments, secure monitor reconfigure the content of PMP entries. And only the memory region which are allowed to be accessed by the current execution environment are configured into the PMP entries. To prevent secure monitor unintentionally temper the memory of a less privileged execution environment, RISC-V ePMP can be enabled to provide the supervisor memory access prevention and supervisor memory execution prevention protections. And this can further strengthen the security capability. So Andes OP-TEE solution provides secure boot mechanism. So each system image is signed at the deployment stage. During the booting, the bootloader verifies the signature of the next stage image. And ensure the only verified image can be safely loaded and executed to enforce chain of trust. Any temper or unverified image will be rejected and the boot sequence will be blocked. The boot sequence ensures the initialization of the T is prior to the read, and letting T have a chance to initialize and enable the vendor-specific security mechanism. Okay, so OP-TEE Secure Monitor is a popular open source secure monitor project inside the RISC organizations. And the OP-TEE design goal is to do isolation and a smaller footprint and portabilities. It supports global platform T API. And the RISC project, this RISC project is owned by Andes. And we're happy to bring the OP-TEE to the RISC-V ecosystem. Let me introduce you to the MCU-T Secure Monitor as part of Andes Century framework. We plan to open source the MCU-T project. MCU-T running on the RV32 with no MMU and the DRAM, and work with only the MO and UMO only. And it requires 16 or more PMP and ePMP entries. And it also supports bare metal or RTOS like a Zephyr. And one of the key features is supporting per zone debugging. And this is a perfect security platform for automotive ECU, which require a fast, predictable interrupt response. Security is a complex issue. Andes cannot do it alone. So we have a partner around the world to work with us to set up this platform. A company like Rambus Security IC, Secure IC, and Puff Security. So if you are interested in working with Andes, please contact us. We would like to work with you and to set up the secure platform with our global partner. Thank you so much. I would like to invite Paul here in case you have any questions. Hey, Paul. Yeah, you might want to come down here because you might get echo if you stay down there.
Have you considered implementing UEFI secure boot using this OP-TEE framework? Like maybe some UEFI runtime can be running in the T to provide like runtime UEFI variables to facilitate secure boot, and then because you already have verified ROM, then it can establish chain of trust. Have you considered that?
Yeah, I think it's under discussion, but actually it depends on the requirement, the strength of requirement. If the momentum of the requirement is getting more and more stronger, we will move to that. We discuss it a lot internally. Thank you.
I saw your reference stack as no HS mode. Are you planning on working on a reference stack with HS mode? And if so, are you going to feel the need to have something like FFA coming from the ARM ecosystem?
You're talking about MCUT or the optic?
No, or the optic question there.
Yeah, the current version, we don't support the HS mode so far.
Yeah, maybe in the future.
Hi, Paul, and Bing. What kind of interrupt latency have you guys achieved on your MCU, the last MCU platform you guys have shown?
Very good question. It depends on processor, actually. If you like, you can visit our booth so I can give you more details.
Okay.
It depends on the processor. We have a series of processor to enhance the latency, even the hard staking or something like that. So
Okay, good.
the exact number, please
Sure,
visit us.
sure.
Yeah, different processors might have a
Yeah.
feature to enhance the latency.
Absolutely.
So please come talk to us.
Sure,
We can
sure,
give you the detail.
Okay, great, thanks.
Secret, right? Yeah. Okay.
It's a very similar question. Maybe you'll give me the same answer, but what's the switch latency time between the two domains, between a trusted domain and the untrusted domain?
Yeah, actually, I don't have the exactly cycle number right now, but we can answer you later when we check the data sheet.
Yeah, please come to our booth. We can provide that in private. Yeah.
Sorry.
You know Paul, so
Yeah.
we'll get you that information. Yes.
I think we're done with questions. So thank you guys. We really appreciate it.
Thank you.